Hi guys, let's jump into another video. And as you also on the previous session, we were talking about implementing durable functions. As part of that, we spoke about discover for function types. Just a recap, we had orchestrator functions, activity functions, entity functions, and client functions. So Coolio, what I'll then do is jump into explore task hubs. So task hubs in durable functions. A task hub in a durable function is a logical container for durable storage resources that are used for orchestration and entities. So orchestration and entities use task hubs, and these task hubs are essentially logical containers for durable storage resources. So this is what basically durable functions use to actually store what you call their state essentially. Uh, Orchestrators, entities, and activity function can only interact when belonging to the same task hub, right? So for functions, entities, and orchestrators to interact, they need to belong to that same task hub so that they can listen to the same events and all of that, which makes sense. Each function app must have its own task hub. Each function app must have its own function of a task hub name, where multiple task hubs can be in the same storage account. So you can have multiple task hubs in the same storage account. So that means task hubs can share what you call the same storage account. When you use multiple functions in the same storage account, typically you'd have task hubs named differently. So that's what that statement means. A task hub in Azure storage consists of, or what makes up a task hub. So these are the components that make up a task hub, which is one or more control queues. Task hub is also made of one work item queue. A task hub is made of one history table. Task hub is also made up of one instances table. A task hub is also made up of one storage container, right? Containing one or more list blobs. So the storage container will have one or more list blobs. A task hub is also made up of a storage container containing large massive payloads if applicable. So if you have payloads that are very big that you use on your durable functions, they'll also be stored in a container essentially. Then the rules for task hub names in Azure storage. So like most services, they can only contain only alpha numeric characters. So it can be something like test hub 123 alpha numeric essentially, right? So it says starts with a letter, so you can't start it with a number or anything. Has a minimum of 3 characters and a maximum of 45. So we see a trend of 3 to 24, 3 to 45 in this case. Some others have, let's say, 200 and something characters limits. Task hub name differentiates between different task hubs in storage account. So the task hub name itself, it makes us uniquely define what you call task hubs in a storage account. Hence why each task hub has to have its own name, which makes sense. Here I'm gonna say explore durable orchestrations, characteristics of an orchestrator function. So how do we say this is like an orchestrator function? So an orchestrator function defines function workflows using procedural code. No declarative schema or designers needed. So it uses what? Procedural code. Orchestrator functions can call other durable functions synchronously and asynchronously. So an orchestrator essentially what it does, it calls other durable functions synchronously or asynchronously. Orchestrator functions are durable and reliable, no loss of state. So they know how to store state and are reliable to maintain that particular state. Orchestrator functions can be long running, so from seconds to never ending. You can have an orchestrator function that runs for days if needs be, or whatever the case might be. orchestration identity. Each orchestrator instance has an instance ID. So each orchestrator instance has its own instance ID. By default, an orchestrator have auto-generated GUID as instance ID. So Azure essentially assigns a new GUID to this thing and it gives that to the orchestrator. You can manually set instance ID to a string value. So if you wanted to change the GUID, you can set it to whatever string value you wanted, right? The orchestrator instance ID must be unique within a task app. So you cannot have the orchestrator ID being shared. So if you have an orchestrator and a sub-orchestrator, say for example, those cannot share the same instance ID. That's what that means. Reliability of durable functions, orchestrators is orchestrator functions use event sourcing pattern, right? To manage state. So they listen to events. Once an event happens, they change the state to some degree and all of that, right? Full series of actions orchestrator takes is stored using append-only store, right? So it says full series of actions orchestrator takes is stored using append-only stores. Then if you wanted to find out more about durable functions, there's a link there. I'll try all means to try open that for you guys. No. Oh, that is bad. That is bad. Anyways, please pretend as if you didn't see anything. So cool, durable function orchestrations there. You wanted to see more information, basically I'm talking about this section, but I've summarized it essentially. Then features and patterns of what do you call durable functions. The table below describes the features and patterns of orchestrator functions. Pattern of feature, then there's a description there. So pattern of feature, we have sub-orchestration, which makes sense. You have an orchestrator that has an orchestrator internally. Durable timers, external events, error handling, critical sections, calling HTTP endpoint, passing multiple parameters. It isn't possible to pass multiple parameters to an activity function directly. The recommendation is to pass in an array of objects to use value tuples objects in .NET. So you can't pass in multiple parameters into an activity function. You can only pass in one. But if you want to pass in multiple, you can pass in an array actually of value tuples. That's what they use in .NET. Calling HTTP endpoint. Orchestrator functions aren't permitted to do I/O. The typical workaround for this limitation is to wrap any code that needs to do I/O in an activity function. Orchestrations that interact with external systems frequently use activity functions to make HTTP calls and return the result to the orchestration. So because you can do I/O operations, therefore you can make external calls or HTTP calls using an orchestrator function. So what you need to do is pass in whatever parameter into another activity function that does the HTTP call, returns a response to the orchestrator function. Essentially, that's what they mean. Critical sections. Orchestration instance are single threaded, so it isn't necessary to worry about race condition within an orchestration. This is interesting. However, race conditions are possible when orchestrations interact with external systems. To mitigate race conditions when interacting with external system, orchestrator functions can define a critical section using lock async. So if you know about locks in .NET, that's typically what they say. If there's a possibility of this happening, just use locks. However, orchestrators, you shouldn't be worrying about that unless if they depend on external sources. Error handling. Orchestrator functions can use the error handling features of the programming language, existing patterns like try catch. So similar to what you do for error handling in C#, any other code, you can use that essentially. External events. Orchestrator functions can wait for external events to update an orchestration instance. This durable function feature often is useful for handling a human interaction or other external callbacks. Durable timers. Orchestrations can schedule durable timers to implement delays or to set up timeout handling on async actions. Use durable timers in Orchestrator Function instead of Thread.Sleep or task.delay, or set timeout and set interval in JavaScript. So they do not recommend that you use Thread.Sleep, but they recommend that you use durable timers instead of those type of thread manipulation methods. Orchestrator functions call activity functions, but also other orchestrator functions. For example, you can have a large orchestration out of a library of orchestrator functions, or you can run multiple instances of an orchestrator function in parallel. Cool. Yeah, I think okay. Let's go up a bit. Okay, control timing in durable functions. And one, I shall job. Okay, regards. Yeah. Cool. I'll cut the video here. When I come back, I'll talk about control timing in durable functions, then talk about send and wait for events. And after that, we'll be done with this module. So this will be a very short video. Sorry about the last part. Thank you.